How is the black lead inserted into it so perfectly? How do car airbags, which save thousands of lives every day, inflate almost instantaneously during an accident? And perhaps most intriguingly, when and why was the very first airbag invented? Once again, welcome to our channel where we explore the fascinating science behind everyday objects. In our daily lives, we use countless products whose benefits we take for granted. However, very few of us truly understand the effort, precision, and advanced techniques involved in making them. Today, we are going to look at the detailed manufacturing processes of 5 such products that we use almost every day. These include airbags, aluminum foil, bulletproof glass, pencils, and sugar. Let's start with the airbag, a life-saving innovation. The idea of the airbag first came to an industrial engineer in 1950. He was traveling with his family when they were involved in a serious car accident. Fortunately, everyone survived. But this accident gave the engineer a crucial idea: there should be a device in cars that can protect passengers in the event of a collision. 2 years later, he created an airbag that inflated using a compressed air cylinder. However, there was a major problem. The inflation process was slow, and during an accident, even milliseconds can mean the difference between life and death. For several years, engineers could not find a faster and more reliable solution. Then, in 1967, an American engineer proposed a revolutionary idea. Instead of using compressed air, he decided to inflate the airbag using gas produced by a chemical reaction. The chemical used is sodium azide. During a collision, the car's sensor sends an electrical signal to the airbag. This signal triggers the chemical inside to explode instantly. The explosion releases nitrogen gas, which inflates the airbag in less than 20 milliseconds. In the blink of an eye, the airbag can expand 5 times its original size, cushioning passengers effectively. The material used to make airbags is unique and specially designed to withstand extreme forces. It is made from thick nylon threads, woven together using 1,000 strands at a time. If even one thread breaks during the process, the machine automatically stops. Although the machine works at high speed, it produces only about 8 meters of fabric per hour. Once the fabric is woven, it is washed thoroughly to remove impurities and ensure strength. After washing, the fabric is passed through heated rollers to dry and press it. Because airbags must hold a high-pressure gas, they are coated with silicone to make them airtight. Computer-controlled rollers evenly spread the silicone. Next, the fabric is passed through large ovens to ensure it is completely dry. Finally, computer-operated machines cut the fabric into precise shapes for different types of airbags. Each airbag undergoes inspection, stitching, and testing before it is installed in a vehicle. Now, let's talk about aluminum foil, another common household item with a fascinating manufacturing process. Aluminum foil is incredibly thin, but it starts as massive, heavy blocks. Have you ever wondered how a block of aluminum weighing tons is converted into delicate, tearable sheets? First, small pieces of pure aluminum, called ingots, are melted in a furnace. It takes about 8 hours to melt 27,000 kilograms of aluminum. The molten aluminum is filtered and purified to remove any impurities. Next, it is poured into a die to cool and form large rectangular blocks, each weighing about 75 tons. These blocks are lifted with cranes and placed on milling machines. Heated rollers gradually reduce the thickness of the aluminum block. After each rotation, the rollers move closer together. A 45 centimeter thick block is passed through the machine only 15 times, reducing it to 5 centimeters. This sheet is then sent through another machine to make it extremely thin, forming the aluminum foil we use today. During the thinning process, the edges can get damaged. Cutter blades trim the damaged edges, ensuring uniform sheets. Finally, the thin aluminum is rolled into coils, ready for packaging and use. It is remarkable to think that something so light and delicate begins as a massive 75-ton block. Next, let's examine bulletproof glass, which can stop bullets yet appear transparent like normal glass. A 9mm bullet can easily pierce a thick steel plate, so how does bulletproof glass resist it? The process starts with normal glass that is heated in an oven and bent. Bent glass is significantly stronger than flat glass. 4 layers of bent glass are stacked together, with a layer of PVB, polyvinyl butyral, inserted between each. The PVB not only holds the glass together but also absorbs the energy from a bullet. The edges of this glass sandwich are taped, and the plastic sheet is wrapped around it to make it airtight. Using a vacuum pump, all the air is removed. Then, the assembly is placed in a large container under high pressure, 10 times greater than normal atmospheric pressure. The container is heated to 278 degrees Celsius. This fuses the PVB and glass layers together, creating a single, solid unit. When tested with a bullet, the outer layers disperse the energy, the PVB absorbs it, and the final layers prevent penetration. This combination of materials and design makes bulletproof glass incredibly effective. Now let's discuss pencils, a tool almost everyone has used in their life. Although often called lead pencils, pencils do not contain lead. Instead, they contain graphite, which leaves a black mark on paper. The first pencil was made in 1630. At that time, graphite resembled lead, so people mistakenly believed pencils contained lead. This confusion was corrected in 1789, but the name lead pencil persisted. The manufacturing process of pencils is intricate. Graphite is mixed with clay to form a paste, which is then pressed through small holes to create identical rods. These rods are baked in ovens to harden them. For colored pencils, pigments are mixed with clay instead of graphite. The pencil casing is made from wooden slats with grooves for the graphite or pigment rods. Glue is applied to hold the rods, and another wooden layer is placed on top. This sandwich is dried to ensure the wood and glue bond firmly. The pencils are then cut to size using milling machines. They are painted, stamped, and tested for quality. Finally, the pencils are sharpened and packaged for sale. Finally, let's explore sugar, one of the most important products in our daily lives. There is a fascinating science behind transforming sugarcane juice into pure white sugar crystals. First, sugarcane is harvested and transported to a sugar mill. It is washed several times to remove dirt, sand, and stones. The sugarcane is crushed to extract juice. This juice still contains impurities, which must be removed before crystallization. The juice is boiled and mixed with a lime solution. After several hours, the color changes from brown to yellow, and the pH normalizes. The juice is left in tanks so impurities settle at the bottom. The cleaned juice is then collected, while the leftover fibrous pulp is used as fertilizer. The juice is boiled further until water evaporates, leaving a thick syrup. This paste can be frozen to make jaggery. To produce white sugar, a sucrose solution is added, and the paste is centrifuged. High-speed rotation removes water and leaves behind sugar crystals. The sugar crystals still contain moisture, so they are dried using hot air. Once dry, the sugar is ready for packaging. Modern machines can produce more than 200,000 packets of sugar in a single day. Now, you can appreciate the incredible effort, science, and precision behind everyday objects. From airbags saving lives, aluminum foil in our kitchens, and bulletproof glass protecting us, to pencils and sugar we use daily, each has a fascinating story of technology and innovation. Nazreen, tell us in the comments what you think about today's topic. We hope you enjoyed and will share this video from Zoom TV. Thank you very much for your support and kind comments. See you in the next exciting video.